Okay, before we look at the homework on chapters 14 and 15, let me just say a quick word about the intent of this. Please do your homework using SPSS. The intent of the course is to not only be able to analyze the data, but also do so using SPSS. And so if you can't do it that way, then we're not really carrying out the intent of the course. So I've had a couple of questions about that. Homework question 1411, the compliance with authority question. This is a classic experiment mentioned in social psychology, and you can actually see some YouTube videos of this. This has actually been going on. I'm not sure if these are real data from that or not, but the intent is that to ask how compliant are people in terms of whether they're motivated by or encouraged by one person or a committee. So I've got some people who are encouraged, so to speak, encouraged by one person, some people who are encouraged by a committee, and we can compute compliance scores depending for everyone, and then we also know whichever group they come from. So if you look at the data on page 312, you've got two columns, but every number in that box is a compliance score. So a compliance score is one of my variables. So I'm just going to call one of them compliance. What's the other variable? The other variable is which group it comes from. So my other variable, I'm going to put, I'm just going to put group. How about that? Now, the groups are, again, either committee or solitary. So I'm going to label these things by clicking over on values for group. And I'm going to use ones and twos because we got group ones and twos, so being not very imaginative. Two groups, one's going to be group one, the other's going to be group two. So group one, I'm going to let that be the committee group. So when I have it labeled, I'm going to type in a 1. It's going to tell me when it talks about group 1, by the way, don't forget this is the committee group. And then group 2, I'm going to label as the solitary group. Click Add so it knows that you're through talking about it. When I click OK, notice in my value column that it tells me the information I just gave that. Or at least it tells you as much of it as they have room to show you. So when I click Data View, these two variables, compliance and group, are going to be my column headings. So I'm going to enter all the compliance scores in, and those are just going to be 2, 5, 20, 15, 4, 10, and then 3, 8, 7, 10, 14, and 0. Now I get all those in okay, double check me. It's easy to miss things. So the first 6 are committee. So I'm going to give these first 6 a code of 1. And then the other groups are group 2. So the second 6 I'm going to code under group as 2s. Okay. So far, so good. I'm trying to monitor what anybody wants to say online. So I'm ready to analyze, so we go to Analyze. And group, I'm going to compare the group 1 mean with the group 2 mean, see if there's any significant difference. So I'm going to go to Analyze. I'm going to compare means, which is where all 3 of our different kind of t-tests are, where they come from. And these are independent sample t-tests. Again, if you're in one group, you're not in the other. So when I click this, I'm going to get that window with the 2 boxes, one left and one right. And I need to identify my test variable and my grouping variables. So what's my test variable? What's my grouping variables? And it's kind of hard to mess this up. What do you suppose the grouping variable would be? Oh, I don't know. Maybe group. Yeah. Again, not very imaginative, but yeah, it's okay to be obvious. It's easy to remember things that way. So group is my grouping variable. And it wants to know, well, how are you coding these things? Well, we had groups 1 and group 2, so I called group 1, 1, and group 2, 2. Kind of hard to mess that up unless you want to put A and B or, you know. Oh, yeah. Okay, you can mess it up. Yes. Yeah. One is 1, 2 is 2. Yeah. Thank you. So you can mess it up. All right. And my compliance is what we're testing. And I think it says use it to 0.05 level of significance. So the 0.05 level of significance corresponds with a 95% confidence interval, which my default's already there anyway, so I don't need to worry about changing that. So nothing else to ask for. So we're going to click OK, and we're going to get an output window like this. I just have to decide how much of this I can show. Let's see, can I open that up some? I cannot. Okay, that's fine. Okay, now remember that I labeled these things the way I want them, so I've got my groups, or one is called committee, one is called solitary, so sure enough it gives me those names because I told it to. So the means, the committee group has a compliance score average of 9.33. The solitary group has a compliance score average of 7, so it looks like the more people who are trying to encourage you to or convince you to do something, even if it's something you don't want to do, it looks like the compliance scores are higher when you're encouraged by a committee. Well, let's see if there's a significance, if they're significantly higher or not. So I've got means and standard deviations, and I'm going to look at the bottom bottom table, and I'm going to look at the first line. I'm going to ignore this second line. Now, I'm going to say a word about that here in just a second, though. I'm going to ignore this for right now. I want my t-value, my degrees of freedom. By the way, where does 10 degrees of freedom come from? There's 5 in one group, 5 in the second group. That's 10. Or 12 people altogether minus the number of groups, which is 2, which is still 10. My significance is 0.522. So somewhere I'm going to write t of 10 for 10 degrees of freedom is equal to 0.663, and p is equal to 0.522, which means it is not significant. So the difference between the 9 and the 7, that's a difference of, the difference between 9.3 and 7, these two numbers right here, that difference is the 2.333. That's not enough of a difference to get excited about. So it's not a significant difference. If, however, the n was larger, that difference of 2.33 might be a significant difference. I don't know. There's just not, we didn't have enough cases to really make that case that there's a difference. The other thing I'll point out before I go back to this equal variance thing in just a second, like I said I'd do. The confidence interval. This is the confidence interval for the mean difference. So the confidence interval is for a mean difference of, the mean difference is 2.33, but you know that mean difference really could be as low as -5, meaning the one is higher than the other, or as much as 10, meaning the other is higher than the one. But the key thing here, when there's not a significant difference, again, this is for a two-tail situation like I've got here, that p is equal to 0.522, that mean difference could be 0, meaning there's not a mean difference at all, or there may well not be a mean difference at all. So because 0 is in the confidence interval, that is consistent with that p-value of 0.522, which is not consistent, or which is not significant. Let me make one other comment, too. Again, I will get back to this equal variance stuff in a second. I'll make one other comment, and that is that the key thing in this analysis, this output, and every other one is the p-value. Is p less than usually 0.05? In some of the homework, several of you refer to the critical value, and that's fine, but you don't really need the critical value when you have a pretty specific p-value. So it doesn't matter if t exceeds or does not exceed that critical value. If you've got the p-value, which we do here, that's the key thing to tell if there's a significant difference or not. So don't worry when you're doing these things with SPSS. Don't worry about what the critical value is. You can if you want to. It's not wrong to say it. It's just unnecessary. Now the other thing I want to point out while we're here, and I think we've done enough of these things, I can say this without confusing you on some of the other stuff. Oh, there it comes. Okay. Let's go back to this equal variance is assumed or not assumed part. That has to do with this part. Now, equal variance, as we made the case from, about, I guess, day one of the class, is that variation makes a key difference in what your findings are. I'll give you an example. Recently, chaired a dissertation defense from the medical school, and one of the things we tried to find out was that, based on your college GPA, did that make a difference on your medical school GPA? Turns out it didn't, because everybody had a high college GPA, so there was no variation in it, so it didn't factor into anything. So the question is, if the variances are relatively the same, whether there's a lot or not a lot, if the variance is relatively the same, then we're going to use the top line. And the way you tell that is, again, by the significance number here. So we use the top line if they're relatively the same, meaning not significantly different. So we use the top line if this is larger than 0.05. We use the bottom line if it's less than 0.05, meaning there is a significant difference, so they're roughly not equal. Now, I've said so far, for our purposes, just ignore that bottom line, and that's still mostly going to be true. It's going to almost always be the top line. I say almost always, about 95% of the time. Hint, hint, hint. And even if it is the bottom line that you use, look how close these significance numbers are to each other. It's going to be rare, hint, hint, rare, that you get a difference in whether something's significant or not if you use the top or bottom line. So it doesn't matter except in real close borderline cases. Also, the weird thing is you get some weird degrees of freedom when you use that down there. And sure enough, if you use, that's what you report. It makes sense for us to have 10 degrees of freedom. Well, how do you get a fractional of a degree of freedom? Well, it's because you're doing some other weird stuff behind the scenes, bottom line. The question was, how do you report that? You would report it the same way. You would report it T for parentheses 9.006. You don't round it, no. You would say, however, I would suggest you say, if you're writing it up and you need to do that, I would say we're using the equal variances not assumed. We're not assuming equal variances because the key number here is less than 0.05. So I would say if you're not assuming equal variances, you need to say you're not. But that will rarely come up. Okay. So okay with all that at home too? Again, it's not terribly important, but I've gotten questions about it, and I just think for the sake of completeness, I need to have discussed it. If you don't follow with that, it's really not a big deal because, like I say, the vast majority of the time, it's not going to make any difference anyway. Once in a while, it will, but we'll deal with that when it does. If it makes a difference in your dissertation data, we'll deal with that. Any questions about Homework question 1411. Again, want to make sure we're all equally, relatively unhappy. All right, let's skip over to 15.8, which is from Chapter 9. And this is an example of a paired sample t-test. So let me close up what I've gotten before. Don't need to save anything. I'm going to open up a blank SPSS document. Close the output window that tells us, hey, you opened up something. Well, I know that. I meant to. So the scenario here begins on the bottom of page 333, about the last third of the page, is, and I'm a little uncomfortable with the way they word this, let me just be honest too, because they start off by saying a psychologist wants to determine whether a new anti-smoking film reduces daily consumption of cigarettes or not. Well, I'm not comfortable with knowing the film is what caused a reduction if there is one. I'm comfortable with finding out if there's been a reduction, but how do you know it was the film that made the difference? I don't know, maybe a favorite teacher or something got lung cancer during that time. I don't know. You know, it could be some other kind of weird thing that got their attention about smoking. But so we can see if there is a significant reduction. And this is a paired sample t-test, so you've got two different kinds of data. Now they're all cigarette consumption, but the difference is one is before and one is after. But it's paired because I've got the before score for the same person that I have the after the film score. So it's paired data. And let me also make the point that if you have paired data, this is a little higher level analysis. If you have paired data and there is a significant difference, you're going to be more likely to find that significant difference if you run a paired t-test than if you run these independently. I could just run the before scores and the after scores independently, but I would lose some of the depth of the data that I have, so I don't want to lose that. Matter of fact, I'll go back and run that in a second. You'll see what I mean. But let me do it the way it says first of all. So I'm going to just simply put in, and these are number of cigarette smokes. I'm just going to say before film and after film, just because that's the way they say it too. And again, keep in mind you can't put a space here; it'll yell at you. Watch this. I'll do it. You'll see what I mean. After film. Oops. See, the variable name contains the illegal character. It doesn't like the space. So I have to go back and type it in without the space. After film. And it's going to like this. There. Didn't yell at me that time. So we go to data view, and those become column headings again. So my before film cigarettes smoked are 28, 29, 31, 44, 35, 20, 50, 25. And then the after film, the cigarettes, the number of cigarettes smoked are respectively 26. So which is the same person, from the same person who scored 28 before the film. Okay, he smoked 2 less, that's fine. Then 27, 32, 44, 35, 16, 47, 23, yeah, and that evens it up. So I have 8 pair of data. So to do the analysis, we go to Analyze. We're going to compare means. And this is a paired samples t-test, if I can get my book out of the way to do this. Try it again, good. Paired samples t-test. And I just need to make both of these for variable 1 and variable 2 under pair 1. That's the only pair I have, so I just move them both over there. I think I'm told, or to use the 0.05, I am, so I don't need to do anything differently than my confidence interval of 0.95 tells me that it defaults to. So I'm going to click OK, and I'm going to get an output window. And there's my output window. And a couple of things I want to keep in mind. So, before and after film, everything here is what's pretty important. Now, so before the film, we smoked an average of 32.75. After the film, we smoked an average of 31.2. That difference between the two, which is a little less than 1, that turns out that is a significant, actually about 1.5. It turns out that is a significant difference because if I look at these three pieces of information, I'm told that T for 7 degrees of freedom, where does 7 come from? That's my number of pairs minus 1 because we're analyzing pairs. 2.51. What's my p-value? Oh, and let's be careful because remember the question is we want to know whether there are fewer cigarettes smoked. If there was a reduction, that's a one-tail test. So, P is equal to 0.02, which doesn't make a difference in terms of what our findings are, but it gives a more precise p-value. So, because P is less than 0.05, there's a significant difference. And I think if you look at, I think this has the answer at the back of the book, and it does give you the p-value. Well, it actually just says P is less than 0.05, but because it's not going to give you that specific one. So there is a significant difference. There was a significant reduction in the number of cigarettes smoked after the film than it was before the film. But again, I cannot say it was the film that caused that. It could have been something else going on. As an added bonus, I've also got a correlation. So remember, R for 7 degrees of freedom is equal to 0.988. So there's a significant correlation, which means that if you smoked a lot before the film, you're still going to smoke a lot after the film. Even though it was fewer, but still more so in relation to the amount other people smoked. So you get a little bonus of the correlation when you run a pair t-test like this. Now, keep in mind what this was. This was my t-value is 2.51. I'm going to write this down because I'm going to remember it. And my p-value ended up being 0.04 divided by 2. Let's run the same data as an independent samples t-test. Just for fun, because we love doing stuff like this. Let's go back and change. Let's go back and see if I can get out of here. So let's just go back and take all the cigarettes smoked as one variable, and then we'll denote each one whether that was before or after the film. So I'm just going to enter in all these numbers. Again, I should have copied and pasted, but I didn't because I didn't think of it in time. My first 8. Okay. The first was, we'll call the group 1 before. I didn't go back and label those, but that's okay. So we had 8 of each of these. So I'm going to label the first 8 coming from the before group, and then the last 8 as coming from the after the film group. Okay. So if I run this as an independent samples t-test, I'm just going to do this real quick. I'm not even going to talk through it, except to myself, probably. Okay. Oh, this makes my point better than I thought it would. If I don't take into consideration the pair, if I just look at how many were smoked before or after, look at my p-value. Now again, we want to turn this into a one-tailed p, so it's going to be p is equal to whatever 0.773 divided by 2 is, so 0.387 roughly. That's way, way, way above significance. So if you've got paired data, run the paired data, because it's more likely you're going to find significance that's there if it really is there. Here, there is significance there, but we missed it because we didn't consider the way the data were paired together. So being paired together is very powerful. That's why we talked when we talked about the lecture part of it, we talked about things like where you match scores based on GPA, for example, because that kind of factors in GPA as being, or takes out GPA as being the cause for whatever significance you might be, because that's not what you're measuring. So if you pair data together some way, it's much more powerful than just running this group against that group. Having some audio issues. Some of you are, some of you aren't. Apparently. Usually everybody says so or not, but okay. Okay, so thus endeth the epistle of the homework for today, if that's clear, unless there are no other questions. If there are other questions, I'll cut this off and move to the next part. So we okay with the homework questions? Hearing no objection, we'll consider that this is done then.